Hello and welcome guys to the machine learning tutorial. So before we jump into machine learning, I would like to give a brief about visualization as well as some mathematics behind machine learning like eigenvector, linear algebra, those things. So let's start. So what is visualization? It's a art of imaginary. Okay, so basically there is a quote called one picture is worth 1,000 words, like that only. A image, or you can say a graphical representation of data, can tell us more than just a number, right? And that's the power of visual imaginary, right? A message which cannot be conveyed through a uh, you know large set of text or numbers or tabular data, that can easily be presented using visuals. We basically often use graphics to make sense from large complex set of information, and that's what visualization is. Okay, so what's the problem with numbers basically? So to understand what is the problem with numbers, let's go to this website graminer.com and we'll see an example. Okay, so this website contains data for different decades, score, who was the player, all those things. So let's go to this one, Sharjah Cricket Stadium. Okay, so this is the data basically telling us in Sharjah Stadium, which is in Mumbai, basically which player scored how much at what strike rate. Now can you see, I mean, how easy for us to convey a message to any people by looking at this graph. Now just imagine if you would have the same thing in spreadsheet. It was very hard for us or any people to convey this message that we can, like, currently we are by looking at, we are making assumption that okay, so green is like a strike rate of around 110. Okay, red is like, red or orange is like 20 to 50 strike rate, and how much they have scored in the that number of matches they have single matches they have played. So this is how it is easy for us to convey a message using visualization, and that's how it is important for us in the day to day life. Now let's go back to our visualization. So there is also one another example that I want to show. Software. Okay, here also, like, you will be able to see all different kind of software ecosystem. So let's say we want to see open source. So you will see that clusters of group in in some of the bubbles. So basically it is telling it's a group of software that belongs to same domain, and you will see here what that software basically provide, what is the platform they are providing, is it open source or not. So basically this is like very understandable visualization, like what is a group of cluster for a given software. We have VLC player, we have other players in this cluster that are very popular. They are very open source, they support Windows, Mac, Linux. So this way basically it is easy for us to make sense it out of data, and that is what the problem with numbers. So let's say we have billions of rows and we have sales data. Now without visual representation, no one can able to, like, correctly convey a message like for this year our sale has declined or our sale has made some profit, like that. So we have these type of common charts that we use basically in our day to day life: line chart, bar chart, scatter plot, histogram. So we'll see one by one. So basically what histogram plot is, basically it is also called as frequency distribution plot. So it should be like a bell shaped curve, like a mountain. Okay, so so basically let's say these from 0 to 12, it's a arrival hours, okay, in a day, and we can see at 4 p.m. the arrival of people are very high. So we can make assumption from this that during this time our airport is very populated with peoples, and this time the schedules are very busy. So the fare of flight will be high at that time. Okay, because this is the time people used to travel and basically reach at the same time. So this is a type of message you can convey using histogram plot. Basically at what time, what is the frequency of people are coming into airport or hotels or restaurant, like that. Now we have box plot. So box plot is used for understanding the variation in our data set. It is also used to identify outlier in our data set. So this is called lower bound, and this is called our upper bound. So basically what they represent where our maximum value lies and where our minimum lowest value lie. Okay, and then you will see some dots also. That dots are basically outliers. What I mean by outlier, so suppose in a data set where it's a like class 5 data set, I mean the student of class 5 data set, where age ranges from 10 to 15. Now there is a candidate whose age is 50. Obviously in class 5, like 5 to 10, or up till 20 also, like we will not be able to get a student of age 50, right? That is incorrect. So that is what outlier. So outlier means basically that number that we see is either incorrect or mistakenly taken. Okay, and in between this a lower bound and upper bound, we have interquartile range. So what it basically means, on the lower bound side it's basically saying what where is my 25 percentile, and q3 basically represent where is my 75 percentile, and the whole represents where basically our variance of data is spreaded over basically, and the middle one is basically the median point. Now you can make an assumption that from median point how many percentage of data are lying in the lower bound, or how much lying on the upper bound side. So these type of assumption you can make using box plot, and this type of information you can convey. Now we have scatter plot. So basically scatter plot is used to detect outlier, as well as it used to see the relationship between two different features. Okay, now you can see on the left side we have one feature, on the right side we have another feature. Now you can see most of the data has been lying between this range. Okay, 0.5 to 5000 range. Okay, so you can see that there is positive relationship between these two features, and these point that you see very far from median point, you can assume those are outliers. So like I just gave you an example, outlier are the point who are basically not make sense in our data set. They are like far away from the actual data that is correct. Then we have line plot. So basically line plot is used to represent change over time or change over quantity. Basically, let's say for example on the left side, on the right side that we see, we have three different product. One is tablet, laptop and desktop. As we can see, for tablet and laptop we see growth over time is increasing, and for desktop growth over time is decreasing. This is because nowadays people use tablet and laptop more than desktop. So that's why we can make sense of this, that okay, so sale of tablet and laptop is increasing, so we should be more focusing on the productionizing or manufacturing these two products, not the desktop. Now we have bar plot. So let's say bar plot is used to represent category data. So suppose you want to calculate how much traveler comes to India from different countries, or you can say different region. As you can see, to India from Brazil 4% of people coming out of 100, from Canada 6% of people coming to India for tour purpose. Also you can make sense of this, like in a given company, or you can say in a given restaurant, what is the sale of like different category of product. Let's say pizza, the sale of pizza is 4%, the sale of burger is 6%, like that. So basically there we use bar plot. Okay, now we have pie plot. So pie plot is like a dividing statistical graphics, or you can say sector, product. In a company there are different sector, and then every sector have different type of product that you sell. Okay, so let's take an example. You have a company, and your company's sell these type of sectors. So orange sector, banana sector, apple sector, mango sector. And so basically what you will take out from is this is that basically let's say you have a company and you have 4 sector, like, and you assigned equal number of product to each of the sector. Let's say you have given orange 100 products, mango 100 products, apple 100 products, and banana 100 products. Now you have given 20-25% to each of them. Now you want to make assumption how much each of the sector is basically growing. So okay, so out of that 100 product, how many they have sold within a 1 month. So if they have sold 100%, all the 100 products, then we will like make sense that okay, all the sector is all the sector basically growing equally. That way you can convey this type of messages. Okay, so that's all for visualization. Next tutorial we will be implementing all these plots using Jupyter Notebook, and then we'll move to another tutorial. Yeah, thank you, bye bye.